Power distribution modules, power distribution units, or power management units, whatever you want to refer to them as, these electronic ways of switching power to different circuits are becoming more and more common with aftermarket electronics. We're here with Scott from Haltech to talk about their new PD16. So, Scott, let's start at the start. For those who have maybe been living under a rock and have never heard the term power distribution module, what is it?
All right, so this thing is like you said, a power distribution module. We put a battery cable into it. We can then have a whole bunch of circuits that have switched, fused power out to all of our individual devices so that we don't need to run old school style fuses and relays. And we can also monitor all those power outputs so we know how much current stuff's using. We can turn them on and off based on any of the inputs going into the device. So basically a really, really smart fuse box essentially.
Okay, you touched on a couple of the advantages there in terms of being able to monitor current, for one example, but where are the other advantages? Give us the key advantages why we would want a power distribution unit over and above the conventional switches, fuses, relays that every car's always run.
So straight away, the first thing that I think is lovely about these is the simplicity of the system. So we put one battery cable onto it. We have one wire that goes out, let's say to the hot side of your thermofan, for example. So the number of connections in your wiring harness that you just dropped, the number of components, you've just dropped one fuse, you've just swapped 4 pins on your relay and another connection to the battery. So straight away the wiring complexity, meaning that there's less points of failure, as well as the cost of wiring in the first place. You'll often find that doing a PDM, the cost compared to a bunch of conventional relays, with the labor rates now, you start to end up fairly similar. But like you said, you've also got the advantage of looking at all of the current data and doing your fault detection as well.
I want to just come back onto that point there you've made, because I think it is so easy for people to overlook. Obviously these units are still relatively costly, although they have come down massively in the time that I've been involved in the industry, but we do need to factor the part that's so easy to overlook is if you're paying an electrician to wire your car, the fuse box, the relays and the switches to those, that's time consuming to wire up, so you have to factor in the saving there.
I mean, 100%, and that's the part I love about this so much. Like the Haltech way of this is always, mate, we want to make it simple. So having something like a keypad that's connected via CAN to your ECU, you've got your PDM that's connected via CAN, everything plugs straight in, so we don't worry too much about the wiring with that. Then to have a regular style auto electrician wire a PDM system, it's pretty straightforward. So we're hot switching everything, so that means that we've got, say, again, the thermofan example. One side of it goes to your chassis ground, wherever that is, the other side directly into the PDM. It's as simple as that. So the hours, like you say, that you drop in labour doing that, if you're just paying, say in Sydney, $100, $150 an hour for an electrician to be doing one thermofan and understand how a relay works and crimp all those connections well and then shield them, it adds up pretty quick to the cost of a product like this.
All right. Let's come back to the fusing as well, because the other advantage that I really love about these products is because we're using solid state electronics to switch the current or the power supply to a circuit on and off. We can do fusing in a smarter way. So a conventional fuse, if we end up with a dead short or maybe a product that's just starting to fail, like a pump or something, it's drawing too much current, it exceeds the fusing capability and that fuse pops. That's it. That circuit's dead, and the only way of getting that back live is physically replacing that fuse. Yeah. So just talk to us about how the power distribution module compares in terms of electronic fusing.
Okay, so what we do here, so this system, we've got, as the name 16, we've got 4 25 amp outputs and we've got 12 8 amp outputs. So if we talk about the 25 amp outputs, we can set the fuse current to, let's say, 20 amps, for example. If we exceed 20 amps, the system works like a slow blow fuse. So it's not going to pop immediately. It's going to take a few seconds. Once we're over that current threshold, then it'll drop that output, and then you've got the chance in the software to choose whether you want to retry 5 times, 10 times, 20 times indefinitely, or don't retry at all and simply turn off. Once that's happening, we send CAN data to the dash so that you already know that something's happened. So there's a problem with this particular circuit, it's retried 3 times and it's dropped out. So you now decide as the driver whether you want to pull over and check it. So knowing that is super important because it does save a lot of time diagnosing that on the side of the road.
Definitely, and I mean, in a mission critical situation for motorsport, this can give enough redundancy to maybe limp the car back to the pits. Obviously, it's not ideal, but it might be the difference between ending up pulling over on the side of the racetrack and actually be able to finish an event.
Spot on. So if we do retry indefinitely, you never know, that might be just enough. Again, with our fan example, obviously there's a lot more, bigger things to be using, but it might be just enough that it keeps that fan running, or just long enough to get you to the other end and finish the race.
Okay, now you've talked about the term CAN a couple of times here, and this is a real key element to these units. And just like the high level view there, we've got a 2-wire bus that can send information to and from other products, your ECU, your dashes, and also the CAN switchpad keypad, which I want to talk about in a little bit more detail. So that massively simplifies the wiring. So we've essentially got 4 wires to a CAN switchpad, for example, CAN high, CAN low, 12 volts and ground, instead of wiring each individual switch. But of course, I know that a lot of tuners are put off, and enthusiasts alike are put off by CAN, thinking that they're going to have to actually get their hands dirty, learn a new skill, and start programming CAN templates. What's the case here with Haltech?
So before anything, firstly, thanks so much for doing your CAN course. I did it. I definitely learned some stuff as well. And you're right, CAN is very, very complicated for the majority of users. This system doesn't quite work the same as most PDMs on the market, where we don't offer this with a full programmable CAN template. The way that this system works with the Haltech ECU is it plugs into our CAN network. The system, think of it as a I/O box or an expander on steroids. So as soon as this plugs into the Haltech ECU, you go online with the Haltech ECU. It's recognised as a device that's on that CAN network or that communications network, so that when again with the thermofan example, I go into my Haltech software, I'll select thermofan, I'll select wiring. Normally, before we had the PDM available, you would choose an output. That output you would then wire to your relay and you're away. In this case, you would go into the wiring, you would go through, all of your normal outputs from the ECU are there, but the difference with this product is that as you scroll down, you'll see 8 amp outputs and 25 amp outputs that appear as part of the whole ecosystem. You simply click on 25 amp output, that already assigns that wire, then choose temperatures, choose current limits, choose what the retry states, and you're done. You don't need to know about any CAN protocol. You don't need to type any of that stuff in or import DBC files or any of that sort of stuff.
So from the tuner's perspective, when you're setting it up, it's essentially just like choosing an existing auxiliary output. If you had no PDM, absolutely seamless, plug it in and the ECU software just recognises that it's there and available.
Spot on. So if you've ever assigned an output on any of the Haltech ECUs before, you've already basically used this product. There's simply an output there for you to use.
So essentially the only difference from the programming standpoint is choosing the fusing current level, retries, etc., as you mentioned.
Spot on. Yep.
Okay, let's talk about inputs as well, because you said it is essentially like an I/O box on steroids. So how does that work in terms of the inputs available, and what would we use those for?
Okay, so on this unit we've also got 4 analog inputs and 4 digital inputs. So we can use those for things like wheel speed sensors or diff temperatures or gear temperatures or any of that sort of stuff. It all gets sent via CAN back to the ECU, so we then can log into the ECU or display on the dash, and again, use it as like a style of expander if you've got an Elite 2500 where you've used all your inputs and outputs, or if you've got a Nexus and you've actually used all of those inputs and outputs, you can put more into this as well.
So again, just from the user standpoint, programming seamless, just nothing new to learn, no additional software, just choose the PDM input instead of an analog input that would be on the ECU.
Yeah, and that's the beauty of sort of what we've tried to do with this, is make it so that anyone can grab one of these, plug the CAN in, and it just works.
Okay, let's just come back to that CAN keypad example, because again, this sort of comes back to the simplifying the wiring. I've already mentioned, instead of running individual wires to switches on the dash, we've got 4 wires, so very, very easy, but the flexibility of using a CAN keypad is also pretty special. So how can these be integrated? How can we set up different functions with them, and can we have multiple functions on a single button, for example?
Yeah, so this is one of my favourite parts of the whole system, is that once you've got a PDM and you've taken control over the power of the system, that's when a keypad becomes really important, because you can now use the keypad to do things like overrides on all of your outputs. So say, for example, you want to prime a fuel pump or do a fuel pump override, you simply configure that on your keypad button. instead of having, say, on a keypad like this, which is the 15-button Greyhill style keypad, you'll end up with, you could end up with 30 or 40 wires behind that dashboard. On this thing, it's got 4 wires. Again, there's no points of failure, so straightforward, and all the programming is done in the software.
All right, in terms of price point, because obviously those listening are going to want to know about that, what's the product worth and is it available for purchase at this point?
Yeah, for sure. So the PD16, the ECU only or power distribution module by itself, $14.95, with a 5 meter, what we call a flying lead harness. So that's terminated at the device end, and then 5 meters of all of the Haltech wire color, which is a really nice thing to have, because that's when you set up the inputs and outputs, it gives you the wire colors in the software as well. So it is handy. About $1,900.
Perfect. All right, thanks a lot for your time there, Scott. And if people do want to find out more about that product, where can they go to?
Jump on our website, just haltech.com, or give the guys a call in the office. One of the offices around the world will always pick up the phone and be keen as to have a chat, because we're all pretty proud of the PDM. Mate, bloody nice device, and we're really looking forward to bringing this sort of technology to anyone who actually wants to use it. And you kind of don't need all of that extra experience now. So it's a bit of a different way of looking at it, and we're pretty excited.
Definitely, the simplification is going to be exciting for those who maybe are a little bit terrified of CAN, and for those who maybe want to learn more about CAN, well, as Scott said, we do have a course on that as well. All right, thanks a lot, Scott.
Absolute pleasure. Thanks, mate.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.